In this video, we will be doing a walkthrough of the 2024 O-Level Chemistry Specimen Paper 1. Now, this paper is actually available to the public for download, so you can get it from the link given in the description. And before we look at the questions in the specimen paper, I would just like to give some context as to why is there a specimen paper. Now, a specimen paper is released whenever there's a revision to the syllabus, and in 2023 there was a revision to the O-Level Chemistry syllabus. So let us first look at the three important revisions to the syllabus, first of which is in the syllabus content. There were a few parts to the syllabus that were removed, one of which would be the extraction of iron. So if you come across questions related to the extraction of iron with the keywords blast furnace, hematite, or even slag being a waste product from the extraction of iron, not a description of your work attitude slag. These questions are no longer in syllabus, so you can actually skip them. The other parts would be recycling of metals. In QA, the tests for lead ions are removed. So right now, when you see a white PPT soluble in excess with sodium hydroxide, is only your zinc and aluminium. For the chapter on crude oil, the naming of the fractions for the individual fractions, your petroleum gas, petrol, naphtha, and so on. So the naming of the fractions is no longer in syllabus, and the stating of the use of each fraction is no longer in syllabus as well. So what's important for the fractional distillation of crude oil or petroleum would be that the lighter fractions, or the ones with the smallest molecules, are found at the top of the column, and the one with the heaviest fractions, the ones with the highest boiling points, are found at the bottom of the fractionating column. There were also some content that was added in the form of your biofuel, or specifically your bioethanol, which is obtained from sugarcane, and how it is a renewable and more sustainable fuel, or a carbon neutral fuel. Then there's this part on the recycling of plastics as well. So we learn that plastics can be depolymerized in the form of a hydrolysis of your polyesters. So these are some of the changes to the syllabus content. Another important change would be the exam format. If you look at your TYS, you would see that the past year papers, paper 2 consists of two sections A and B. Your section B, question 1 is a database question, followed by another compulsory question, and then the last question is an either-or question. So starting from 2024, you'll be sitting for the new format, where section A is a whole 70 marks. Okay, your database question would also appear in section A, likely to be the last question in section A. And then for section B, there will be two questions, two 10-mark questions. You're supposed to choose one. I think the new format is a lot clearer. So you know that you have to complete all the questions in section A, and then for section B to choose one out of two. The last important update to the syllabus would be the change in the periodic table. Starting from 2023, we are using the new periodic table, where if you just take a look at the group number, in the past we used to label the groups using Roman numerals, okay, where your transition elements, they do not have a group number. Okay, but in accordance to the IUPAC definition, the new periodic table, actually it's not that new, it has been around for I think more than 20 years. The group numbers are now in your normal numeral form, okay, and your transition elements, they do have a group number as well. And because of that, now your group 3, in the past, your boron, aluminium, gallium, will now in the new periodic table be known as group 13. And your group 4, your carbon, silicon, germanium, will now be group 14. Okay, so I think it's still of value for you to know the link between the two, so that, because when you think of the O Roman numeral, it has a more direct mapping to the number of valence electrons. Okay, so when you look at the new periodic table, however, you need to do some adjustment in your mind, like group 13 actually has 3 valence electrons, group 17 has 7 valence electrons. Now that we have looked at the changes to the syllabus, let us now go into the specimen paper. For each question, I will be going through the chapter that is related to and some of the important concepts. For question 1, we are looking at an experimental design question. So this question talks about a titration. And in a titration, obviously, we need a burette, we need a pipette to measure 25 centimeter cube of your solution into your conical flask. So from the question, we are measuring 25 centimeter cube of sodium hydroxide. So for sodium hydroxide, we must use a pipette. And we are titrating against hydrochloric acid. So hydrochloric acid must be in the burette. And the indicator that we're using is methyl orange. So in the chapter of acids and bases, we learned about indicators. We need to know the colors of methyl orange. We need to know the colors of litmus and also universal indicator. For phenolphthalein, I don't think it's in the syllabus, so you need not know the colors for phenolphthalein. For methyl orange, you need to remember that in acidic solutions, it is red. In alkaline solutions, it's yellow. And at the end point, it is orange. For question 2 is related to separation and purification. We are looking specifically at chromatography. And in chromatography, we learn a term called RF value. For RF value, I prefer it to be defined this way, so that there's less ambiguity and less chances of making mistakes. So how I would define RF value would be the distance of the spot from the start line divided by the distance of the solvent front from the start line. So it's a reminder to you that the measurements are made relative to the start line, and it makes you identify the position of the start line as well. For this particular question, if you don't identify the start line, you may mistake the start line to be the original level of the solvent. Okay, the start line is also where we would put our original spot of mixture or dye. So once you have identified the start line, it will be very obvious that the RF value of the final position would be y over x plus y. Question 3 is again on separation and purification. Over here, we are looking at 2 immiscible liquids. We have learned in the syllabus that when we have 2 immiscible liquids, we need to separate it, or we can easily separate them using a separatory funnel or separating funnel. And then there's a second part of the question where you need to check for purity. In chemistry, there's only one definitive way to check for purity, which is to check for the boiling point or melting point. And we have learned in the syllabus that if a substance is pure, it will melt and boil at a fixed and exact temperature. For question 4, we are looking at kinetic particle theory, specifically the concept of diffusion. So the thing about diffusion in gases is this, that if they are left for a long period of time, due to the random and the high speeds of the particles in a gas, if left for a long period of time, we will always end up with a uniform or a homogeneous mixture. Uniform meaning the colors will be entirely the same. Okay, now even though there is a difference in the density of the two gases, if left for a long period of time, then density would not have any effect. For question 5, we are looking at a mole concept question where we are supposed to calculate the relative molecular mass of a compound. The structure of the compound has been shown, and over here the question states that there are two different isotopes of bromine, bromine 79 and bromine 81. So given the molecular formula of the compound, we need to find out how many different molecular masses are possible. So two concepts to revise. Number one, to calculate relative molecular mass of a compound, we need to sum up the atomic masses of all the atoms in the molecule or in the compound. So in this compound, since there are 3 bromine atoms, and your bromine atoms can exist as either the 79 or the 81 isotope, there are different ways in which we can construct the compound out of the different bromine isotopes. For example, we can have a molecule where all 3 bromine atoms are made of the 79 isotope. We can also have a particular one where all 3 atoms are made up of the 81 isotope, or then we can have a mixture of the two. So there are actually 4 different ways in which we can construct the compound out of the different bromine isotopes, and if we were to sum up the atomic masses, if we were to sum up the atomic masses to get the molecular mass, you will find that all 4 of them would give a different molecular mass, and therefore there are 4 different relative molecular masses possible for this compound. For question 6, we are looking at melting point. Whenever you see melting point, it's related to structure and properties. So over here, we are looking at sodium chloride and magnesium oxide. From the identity of the compounds, you must be able to recall that they are ionic compounds. Therefore, they have a giant ionic lattice structure with strong electrostatic forces of attraction between your oppositely charged ions. Now, when a particular ionic compound has a lower melting point, it simply states that the electrostatic forces of attraction are weaker. For question 7, this is a chemical bonding question, and you are given a dot and cross diagram. Now, for questions like this, it's easy to get distracted by the electrons that are being shared. So the trick to solving these questions is, instead of looking at the sharing of electrons, for each atom, look at the number of valence electrons around it. So over here, the question is focused on Y. So let's take a look at the number of valence electrons around Y. There are 6 valence electrons around Y, which means that Y must be found in group 16. So the question already states to use the periodic table. So if we were to look at the periodic table in group 16, the very first element would be oxygen. And oxygen has an atomic number 8, which means that there are 8 protons in oxygen. For question 8, this again is a structure and property question. So the question states that this substance J conducts electricity in the solid state. Now there are only two classes of substances that can conduct electricity in the solid state. One would be metals, the other one would be graphite. So then the question goes on to tell you that J reacts with hydrochloric acid. So it means that it cannot be graphite, it must be a metal, and not just any metal, it must be above hydrogen in the reactivity series. So over here, copper is below hydrogen, so it is not correct. Now, every single year in O-level, the concept where copper cannot react with acid would somehow come out in some question. So it's very important for you to remember that copper is too unreactive to react with acids. Question 9 again is on structure and properties. They tell you that element X is a metal. So you need to recall what are the properties associated with metals. As mentioned, there's only one property that's unique to all metals, which is that it's a good conductor of electricity, it is a good conductor of heat. All the other properties, there are actually exceptions. For example, when we say that metals have high melting points and boiling points, we would note that your group 1 metals, the melting points are actually relatively low. And then when you think about metals are very reactive, but there are also metals like copper, silver, gold that are not reactive. For question 10, we are given the structure of silicon carbide. Now, even though we don't learn silicon carbide in the syllabus, when given the structure, I'm sure you will be able to see the tetrahedral arrangement and to relate the structure to that of sand or diamond. When two substances share the same structure, they would share the same properties as well. So given that silicon carbide behaves like diamond or sand, it must be hard, okay, and when it undergoes combustion, meaning to react with oxygen, now each element in silicon carbide is then going to combine with oxygen, meaning silicon is going to combine with oxygen to form your silicon dioxide, which we have learned in the syllabus is a solid, and then your carbon is going to combine with oxygen to give you carbon dioxide, which is a colorless gas. For question 11 is talking about graphite. So we just need to recall that graphite has a giant molecular structure. It has two-dimensional hexagonal rings of carbon atoms with weak intermolecular forces between the layers. Now with that, you should be able to answer the question. For question 12, we were asked to calculate the relative molecular mass for propanoic acid. So again, two concepts to recall. Number one is relative molecular mass is the sum of atomic masses of all atoms in the molecule. Second thing is to be able to recall the molecular formula of propanoic acid. Now, for acids, it's tricky. Rather than trying to recall the general formula, I would suggest that you either draw out the structure or to write out the condensed formula. In this case, you wouldn't accidentally add one more carbon to the formula. So the molecular formula or the chemical formula for propanoic acid will be C2H5COOH, and then you just need to sum up the atomic masses to get the molecular mass. For question 13, this is a mole concept question where you're asked to calculate the percentage mass. Now, to calculate percentage mass of anything, you need three pieces of information. You need to know the mass of the part, you need to know the number of parts, and the mass of the whole. Now, in this particular example, the mass of the part that we're looking at is oxygen. So for each formula, we need to look at the number of oxygen atoms in the formula, and the mass of the whole would be the mass of the entire compound. Okay, so the formula for percentage by mass of oxygen will look something like this, where N is the number of oxygen atoms. Now, given that the mass of the part, the relative atomic mass of oxygen is the same in all cases, you can ignore 16, all right? But rather, you just simply compute the number of oxygen atoms over the relative formula mass for all four options and see which one would be give you the largest value, and that would be the correct answer. Okay, so for MCQs, If you can know all these little tricks, it will help you to do the question much faster. Okay, so instead of having to compute the percentage mass of oxygen in all 4 options, you just need to recognize the formula, and then from the formula you can see that N, or number of oxygen atoms over the relative formula mass, will give an indication of which percentage mass is the highest. For question 14, this is a very tricky question. Question gives you 4 reactions and asks you about the change in volume. Now, one very important concept with regards to the change in volume in a reaction mixture is that only gases would contribute significantly to the volume of a reaction mixture. Okay, so when we are looking at the change in volume in the reaction mixture, we should only focus on the gases. Solids and liquids, we can assume the volumes to be negligible. Okay, so to know the change in volume, we simply look at the number of moles of gases before and after the reaction. So the tricky thing about this question is that instead of asking for the absolute change in volume, it's asking for the percentage change in volume. So to know which one has the smallest percentage change in volume, we cannot just look at the change in number of moles of gases, but we need to take the change in number of moles of gases and divide it by the number of moles of gases at the start of the reaction, or the number of moles of gaseous reactants. So for example, if we look at option A, at the start of the reaction there were 3 moles of gases. At the end of the reaction there was only 1 mole of gas. So the change in the number of moles of gases would be 2. So the percentage change would then be 2 over 3. For the correct option, if we look at option B, before the reaction there are 6 moles of gases, and after the reaction there are only 3 moles. So the change in number of moles of gases is 3, and the percentage change would be 3 over the initial number of moles of gases, which is 6. So if you were to compute the percentage change, you will find that B has the smallest percentage change. For question 15, this is a chemical calculation question involving titration. Now for all chemical calculation questions, you can easily solve them using the 3C approach. You'll convert to moles, compare mole ratio, convert from moles. Now the tricky thing about this question is to be able to recognize that the acid used is a dibasic acid. And whenever you have a dibasic acid, remember there are 2 hydrogen ions per mole or per unit of the acid. So when you have a dibasic acid or an equivalent of a dibasic base, you need to check the reacting ratio. Usually it's not 1:1. So for this particular example, since we have a dibasic acid reacting with potassium hydroxide, the reacting ratio is actually 1:2. Right? So if you simply assume a reacting ratio of 1:1, that's where you will get the question wrong. Now for titration questions, there's usually a shortcut that I would recommend for MCQ questions, which is to use this particular formula. Just a quick recap of what this formula stands for. C stands for concentration, V stands for volume, N would be number of moles. Now how do we find the number of, A stands for acid and B stands for the base or alkali. Now how do we find the number of moles of acid over number of moles of base, or Na over Nb, would be to look at the coefficient of the acid and the alkali in the balanced chemical equation. So for example, I've shown above that the number of moles of acid, or the coefficient of the acid, is 1, and the coefficient of the alkali or base is 2. So Na over Nb is just half. Next, you just need to look at the question and fill in the values and substitute in the values for C and V. Right, the powerful thing about this equation is that there's no need for you to convert volume into dm cube. Right, the reason being, even if you were to convert, if you attempt to convert, you will find that the 1000 actually cancels out in the numerator and the denominator. So by using this equation, you can simply keep your volumes in cm cube and to solve the question very much faster. Right, in some questions even the values given are so nice that there's no need for you to use the calculator. You'll be able to get the answer straight away. For question 16, we are looking at a percentage yield question. So the first important thing to do is to recall the equation for percentage yield, which is actual mass over calculated or theoretical mass. In percentage yield questions, most of the time you will be given the actual mass or the actual yield, and then you're supposed to apply your 3C to find out the theoretical mass. So in this question, as per routine, the actual mass of magnesium is given to be 5.9. And then we need to find the theoretical mass by applying 3C. So we need to first convert to moles. So we are given 4.8 grams of magnesium. We just need to convert it to moles. Second C, compare mole ratio between magnesium and magnesium oxide. So the ratio is 1:1, meaning number of moles of magnesium oxide is the same as number of moles of magnesium. And the last C will be to convert from moles to mass. So we just need to multiply by the molar mass of magnesium oxide to get the theoretical mass, which is 8. So the percentage yield would then be just 5.9 over 8 times 100. For question 17, this is a chemical formula and equation question, and we are supposed to write the ionic equation for a neutralization reaction. Now for any neutralization reaction between any acid and any alkali, the ionic equation is always the same. Okay, the ion that makes an acid is hydrogen ion. The ion that makes an alkali is hydroxide ion. So in any neutralization, it is always H plus OH minus to give you water. Question 18 is on salts. This is a typical question as well, where we mix two solutions and you're asked to determine which one produces a precipitate. So the thing about mixing two solutions is that the ions will be mixed together. So you can imagine the ions to be interchanged. So the trick to solving this question is that to interchange the ions and see which combination would give an insoluble salt. For example, if we just look at option A, if we were to interchange the ions, we will end up with barium nitrate and silver nitrate. So both of which are soluble, all right, since all nitrates are soluble. If we look at the correct option now, if we were to interchange the ions, we will get sodium chloride as well as barium sulfate. And hopefully you'll be able to recall that barium sulfate is insoluble. When one of the salt is insoluble, it will come out as a precipitate. Now this question is also slightly tricky in the form of option B, all right, because students tend to carelessly think that barium chloride is insoluble. All right, since barium something is insoluble, but it's important to remember, don't be careless. All chlorides are soluble except for silver and lead, meaning barium chloride is actually soluble. For question 19, this again is a salt preparation question. So this question requires you to prepare lead-2 sulfate. To know which method to use to prepare a salt, you need to first know whether it's soluble or not. So lead-2 sulfate is insoluble, and insoluble salts we make use of the precipitation method. And if you can recall precipitation method, we need to mix two solutions. So the correct option would be one where two solutions are being mixed. So first, A is out, lead is a metal, so it's a solid. Lead 2 carbonate is insoluble, so it's not a solution as well. For option D, we have your lead chloride. Lead chloride is also insoluble in water, so it's not a solution. So the correct answer would be C. For question 20, this is a qualitative analysis question. You are given two tests with the results. It's quite obvious that when you test with hydrochloric acid, the gas given is carbon dioxide, so X contains a carbonate, or X is a carbonate. And then when you warm with aqueous sodium hydroxide, this is a test for your ammonium ions. And then since ammonia is produced, it means that X contains your ammonium ion as well. So X would therefore be ammonium carbonate. For question 21, you are given a series of equations and asked which ones are redox. Now, one simple hack that you can use in the O-level syllabus is this, that whenever a reaction involves a free element, that reaction is likely to be redox. So if we take a look at the first equation, we have chlorine. Chlorine is a free element, so this is likely to be redox. If you look at equation 2, we have zinc and we have hydrogen. These are your free elements, so 2 would be redox as well. And for 3, you don't see any free elements. Okay, so chances are it's not a redox reaction. Okay, to further substantiate that is that there are certain reactions that are not redox in nature, and two famous examples would be neutralization. Any neutralization reactions are not redox. The other one is precipitation. Okay, so if you are observant enough, you would see that equation 3 is a precipitation reaction. This is a PPT, so therefore it is not redox. Okay, but all in all, the quickest way is to look for free elements. If an equation has free elements, it's definitely redox. If an equation has no free elements, there's a high chance that it's not redox. For question 22, this is an electrochem question. So the electrolyte that's where a current is passed into is your concentrated aqueous sodium chloride. Now this is actually a standard case study in our syllabus. For concentrated electrolytes, we just need to look out for chloride. And when we have concentrated chloride, your chloride ions will be discharged at the anode in place of your hydroxide. So if we were to go through the usual procedure of listing the ions at the anode and the cathode, and then looking at what is discharged, you would see that chloride will actually be oxidized to chlorine gas at the anode, and then hydrogen ions will be reduced to hydrogen gas at the cathode. So if you were to run through the options, you'll find that A, B, and C, they are wrong. Okay, for D, why would the pH of the electrolyte increase? Is because if you were to look at the ions that remain, the ions that are not discharged, we have sodium and hydroxide. So after some time, what remains in your electrolyte is sodium hydroxide. For question 23, this is again an electrochemistry question. So they're asking you for which particular setup would there be no change in the concentration of the solution. Now, for electrochem questions, when you see no change in the concentration of solution, this is analogous, or this is the same as that the color of the solution remains blue. Okay, I'm not saying that they're exactly the same, but it should remind you of the case where the color of the electrolyte remains blue. Okay, when that happens, it means that there's no change in the concentration of the solution in the electrolyte, and that happened, if you can recall, when we have an active electrode. So over here, if we take a look at the 4 options, there's only one where there's an active electrode. So immediately you should know that B is the answer. Now, why is it that with an active electrode there is no change in the concentration of your electrolyte? It's because your active electrode at the anode is going to be oxidized to form the ions in your electrolyte. So therefore there's no change in the concentration of the ions in solution. 24 again is an electrochem question, even though it doesn't look like it, that we are just placing 2 metals in an acid. But over here, you can see that the 2 metals are touching, okay, and hydrogen bubbles are formed around copper, which is unusual, isn't it? Because copper is not reactive enough to react with acid. On the contrary, zinc is reactive enough, so hydrogen bubbles should be forming around zinc if this were to be a conventional acid metal reaction. So that tells you that it's not, but rather this is an example of a simple cell. Okay, so in a simple cell, all you need to remember is that the electrons flow from the more reactive metal to the less reactive metal. And once you recall that concept, you would be able to solve the question already. For question 25, this is a periodic table question. So the question states that the element with proton number 12 have similar chemical properties. Now, when you see similar chemical properties of elements, it means that they are found in the same group. Elements in the same group have the same number of valence electrons, therefore they will undergo the same type of reactions. Okay, the reason for that is that because in chemical reactions, it's only the valence electrons that are involved. So elements in the same group would have the same chemical properties. So proton number 12 is found in group 2, and therefore you need to find another proton number that will give you group 2, and in this case it will be your option C. For question 26, you are given some description of element Z. Element Z has a high melting point, so that tells us that it's likely to be a metal. It could be a giant covalent compound, but then it goes on to tell you that it can lower activation energy of a reaction. That is the classic definition of a catalyst. And then from periodic table, we learn that transition elements and its compounds are good catalysts. So over here, immediately you should know that Z is a transition metal. Question 27 is on the reactivity series. So over here, they tell you that chromium is between zinc and iron. So I've drawn out the reactivity series and I've placed chromium in the reactivity series. So which element reduces the oxide of chromium? It's important to recall now that for metals below carbon, the oxides of the metals can be reduced by carbon to form the metal. So over here, we are looking at carbon. If you were to look at the other metals that are other options, all the metals are found below chromium. So all these metals would not be able to displace chromium from its oxide. Question 28 is also on the reactivity series. Now, should you ever see a setup like this again, it's important for you to know that we are looking at the reduction of metal oxide with hydrogen gas. I repeat again, if you were to see a setup like this again, this is the setup for the reduction of metal oxides with hydrogen gas. So importantly, you need to recall which metals or which metal oxides can be reduced by hydrogen gas. And the common misconception is to look for hydrogen in the reactivity series. Now, hydrogen in the reactivity series simply tells you which metals can react with acids and which metals cannot. So there's actually another marker, or your H2 marker, which is just above iron. Okay, so this tells you the oxides that can be reduced by hydrogen gas. So in the reactivity series, metals below zinc, right? Metals below zinc, the oxides can be reduced by hydrogen gas to form the metal. So over here, the powdered solid must be the oxide of a metal that's below the H2 marker in your reactivity series, and that would be only copper. For question 29, this is a chemical energetics question. They tell you that the reaction given is an endothermic reaction, and what can be deduced from this information. So in any chemical reaction where there's bond breaking and bond forming involved, there's no way for us to predict whether it's endo or exo. But should the question tell us whether it's endo or exo, then we can know the total energy, whether is it greater for the energy given out during bond forming or the energy taken in during bond breaking. Okay, note that we are looking at the total energy given out versus total energy taken in. So we are not looking at the number of bonds. The number of bonds don't tell us anything, but rather the total energy given out and total energy taken in. So in this case, the correct answer is D. For C, why is it wrong? The products possess less energy because it's an endothermic reaction. If you can recall the energy profile diagram for an endothermic reaction, the products actually have more energy than the reactants. Question 30 again is a chemical energetics question. Question is also very tricky. The question tells you that calcium carbonate decomposes endothermically into calcium oxide and carbon dioxide. So the reaction, the decomposition of calcium carbonate to calcium oxide and carbon dioxide is endothermic. Okay, but if you were to read the question carefully, they are asking you for the energy profile diagram for the opposite reaction, for the reaction of calcium carbonate and carbon dioxide. So the opposite reaction. If calcium carbonate becoming calcium oxide and carbon dioxide is endothermic, this reaction would therefore be exothermic. So we are looking at an exothermic energy profile diagram. A and C is out. Okay, and then in an energy profile diagram or in an energy level diagram, we always start with the reactants to the products. In this case, the reactants would be calcium oxide and carbon dioxide becoming calcium carbonate. So the tricky part about this question is to recognize that we are looking at the opposite reaction to what is being described in the question. Question 31, this is a rate of reaction question. So we have learned in the syllabus that rate of reaction depends on different factors like concentration, pressure, temperature, particle size, and catalyst. So pressure is one of them, but it's important to note that pressure would only affect reactions involving gaseous reactants. So if a reaction does not involve gaseous reactant, changing the pressure would do nothing to the rate of the reaction. So in this case, if we are looking for a reaction where pressure is least likely to affect, it means that the reactants do not involve any gas, and that would only be option C. Question 32 again is a rate of reaction question. There's this experiment that was conducted with 3 different solutions of hydrogen peroxide. and then you are given a graph and you're supposed to match the graph to the different solutions. So whenever you are given graphs in rate of reaction questions, it's important to recall that in any rate of reaction graph, there are 3 points to focus on. Number one, the initial gradient, which will tell us the initial rate of reaction. The final volume, which would tell us the total volume of gas produced, which also tells us the number of moles of your limiting reactant. And also lastly, the last one is not as important, but the time at which the reaction is complete. So for this question, if we were to look at the 3 solutions, you can see that for solution 2, the concentration of your reactant is lower. And when the concentration of the solution is lower, it means that the initial rate of the reaction will be lower as well. So it will show up in the graph where the initial gradient is less steep. So immediately we can link graph Z to solution 2. Next, to know the final volume of gas produced, we can look at the number of moles of your limiting reactant. In this case, there's only one reactant, so let's look at the number of moles. Since we are looking at solutions and we're given volumes and concentrations, we can find number of moles by taking concentration times volume. And this is just an MCQ, so there's no need to compute exact number of moles. I'm just going to take 50 times 2, so I have 100 moles. And then for solution 2, I have 100 as well. And for solution 3, I have 200. That means that solution 3, I have a greater number of moles of reactants, which will give me a larger volume of gas at the end. Okay, or for solution 3, I have 2 times the number of moles of reactants, meaning I will get 2 times the volume of gas produced as well. So that means that X would be solution 3 and therefore Y would be solution 1. For question 33, we are looking at an organic chem question. We are given octane. From the name ANE, we know that it's an alkane. So we need to look for statements that are consistent with an alkane. Alkanes are saturated, it cannot be polymerized, it cannot undergo addition polymerization. Alkanes again are saturated, it cannot decolorize aqueous bromine. You may be thinking of a substitution reaction, but substitution reaction requires or only occurs in the presence of UV light. In statements like this where you don't see any specific mention of UV light, it means that it will not occur. It has a lower boiling point than methane. You need to recall that the larger your alkane, as N increases, as your alkane gets bigger, the boiling point actually increases. So it should have a larger or higher boiling point than methane. It reacts with chlorine by substitution. That is the classic reaction that alkanes undergo. For question 34, the question is asking for an isomer of propanol. So 2 concepts to recall again. Isomers have the same molecular formula, different structural formulae or different arrangement of atoms. And second thing is to recall that propanol is an alcohol with 3 carbon atoms. Okay, there's actually a very easy way to solve this question, which is to recognize that propanol is actually saturated. Your alcohols are actually saturated. Okay, so when we look at compounds with the same number of carbon atoms, and one is saturated and the other one is not, it means that they will not have the same molecular formula. Okay, because unsaturation would mean you will have less hydrogen atoms. So in this case, if we were to look at the options A, B, and D are all unsaturated, that means that the molecular formula of A, B, and D cannot be the same as propanol. Okay, so if you just want to be careful, you might want to write out the formula of propanol, C3H7OH, and then you compare it to C, option C, and you find that it has the same molecular formula as well, but the structure is different. We don't have an alcohol here. This is actually an ether. Question 35 talks about an organic compound. Options A to D are organic compounds reacting with sodium carbonate. So this is a reaction of an acid, and therefore we know that it must be in the homologous series or the family of carboxylic acids, and therefore the option is straightforward to be B. Question 36. Which acid and alcohol react to form the compound shown? So the compound shown is an ester. I hope you can see the ester functional group over here. For an ester to get back the acid and the alcohol, there are two very simple steps. First one is to find and break the CO single bond. Okay, so once you have broken the CO single bond, what's left to be done is to add back the OH to your acid and add back the H to your alcohol fragment. So from here you can see that the alcohol is methanol, and then the acid would be propanoic acid. For question 37, we are given the structure of a polymer, and then the question is asking for the monomer. Now, when you are given the structure of a polymer, it's important for you to be able to recognize whether it's an addition polymer or condensation polymer. From the structure of the polymer given, you must be able to recognize that it's an addition polymer. And how do you do that is that it doesn't contain any ester linkages, it doesn't contain any amide linkages. Now, some of y'all may say that there is an ester group over here. Indeed, there's an ester group, but it's not linking the polymer together. So it's not considered an ester linkage. This is just a simple addition polymer. So for an addition polymer, how do we get back the monomer? The steps are as follows. We need to first find the repeat unit. The repeat unit in this case would be this. Once you find the repeat unit, the next thing is to erase the bonds at the side, and then you add back the double bond between the carbon atoms. So this is the monomer that gives rise to this polymer. Okay, so from the options given, I hope you can see that the monomer that we are looking at is A. B and D is definitely out because we are not looking at condensation polymers. And then if you analyze the formula of C, it looks different because there's short of one oxygen in the formula. For question 38, this is another polymer question. So this one thing worthy to note is that this question is based on the concept that was added to the new syllabus where we look at recycling of polymers. One method is known as depolymerization or the hydrolysis of polyesters. So over here from the structure of your polymer, I hope you can see there's a polyester. Okay, a polyester can undergo hydrolysis to get back your dicarboxylic acid and diol. So let's take a look at the three statements. The polymer could be nylon. Nylon is the example for polyamide. So one is wrong. The reaction is catalyzed hydrolysis. Yes. So this is from an ester to back to the acid and the alcohol is called hydrolysis. So this is indeed hydrolysis. For statement 3, if the square is CH2, then the product has a molecular mass of 62. So if the square is CH2, yes, it's ethane 1,2-diol or your ethylene glycol. And then if you were to sum up the atomic masses, we do get a molecular mass of 62. Question 39, which diagram represents the structure of pterylene? Pterylene in our syllabus is the classic example of polyesters. So we need to look for a diagram, a structure that contains ester linkages. So in this case, if we look at the structure of B, these are your ester linkages. Now note that these ester groups actually links the monomers together, as compared to the question that we saw earlier. So this is a polyester, this is a condensation polymer. For the last question, which compound is used in flue gas desulfurization? This is a recall type question. You need to know that flue gas contains the pollutant sulfur dioxide, and sulfur dioxide is an acidic gas, so we need to use something that reacts with an acidic gas. And in this case, the thing that we use is calcium carbonate, which will react with sulfur dioxide to form calcium sulfide, and then it will react some more with oxygen to form calcium sulfate. So you need to remember this fact from the chapter of maintaining air quality.